Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is Edexcel 2021, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Generally there's two paper sets each year, so there'll be a June set and a November set. This paper would have been originally prepared for June 2021, but then the exams got cancelled, and so it is now listed on Edexcel's website as November 2021. But there's only one paper from 2021, so if it's got 2021 written anywhere on it, it's the same one as this. Right, let's get cracking. Question 1. Write 3/10 as a percentage. Well, a percentage means per cent, per 100. So what we need to do here is take our fraction, which is a fraction over 10, and change it into a fraction over 100. Now, how many times does 10 go into 100? Goes in 10 times, doesn't it? So if I multiply the bottom by 10, I've got to multiply the top by 10 as well. So 3 times 10 is 30. So that gives me 30 over 100, which I can then rewrite as 30%. So it's 30%. Question 2, write the following numbers in order of size, starting with the smallest number. Well, if you think about the number line, if you've got 0 in the middle and then it goes 1, 2, 3, 4, 5 and so on that way, then the ones that are smallest are the ones that are furthest to the left, aren't they? And you're going to have to put all the negative numbers down on the left. So I think the first, or the smallest of these numbers is going to be this 10 here, isn't it? It's going to be all the way down here. So minus 10 is going to be our first one. Then we're going to get to minus 7 on the number line. Then we're going to get up to minus 2. And then we're going to get to 0. And then finally we're going to get into the positive numbers like 1 and 8. Just check I've got the right amount. 1, 2, 3, 4, 5, 6 numbers. 1, 2, 3, 4, 5, 6 answers. Good. So negative 10, negative 7, negative 2, 0, 1, and 8. Question 3, write 9/100ths as a decimal. So if I got like a number 123.45, then this 3 digit here then is going to be the units digit, isn't it? And then next to it is the tens. That's worth tens, so it's 23, isn't it? So 2 tens and a 3. And then this one here is worth hundreds. Okay, now going back the other way, after the decimal point, this one is going to be tenths, and this one is going to be hundredths. So if I want to express 9/100ths as a decimal, it's going to have to be in this sort of place here, like. So if I'm going to write that down as a decimal, it's going to be 0.09 in that second digit after the decimal place. Question 4, write 327 correct to the nearest 10. Well, the nearest 10, where is the tens unit, tens digit on this number? it's this 2 here, and that's the tens, isn't it? So if I'm going to round to the nearest 10, I'm going to round off after that 2. Okay? Now, when we round off, we just look at the very next digit after the rounding point and decide, is it 5 or more? Do we raise the score? Or is it 4 or less? Do we let it rest? Now, in this case, it's 5 or more, so we need to raise the score. So that 32 goes 1 up, becomes 33, and we need to make it the same size as before. Put a 0 on the end. It's 330 to the nearest 10. Okay, the other way of thinking about it, if you've got a number line and if you had the tens marked on here, so like 320 and 330, then you can see that it's going to be here, isn't it, on the number line? That's going to be 327, so it's definitely closer to 330 than it is to 320, so it's that one. That's another way of thinking about it. Okay, either way, it's 330. Question 5, write down the value of 7 squared. Well, when you square a number, you're timesing it by itself, isn't it? So 7 squared is simply 7 times 7, and I know that 7 times 7 is 49. Question 6a, write down the mathematical name for this quadrilateral. Now you can see, well, a quadrilateral is a 4-sided shape, isn't it? And you can see this shape has got 4 sides. But which 4-sided shape is it? Now it's got these little arrows here. Now that indicates that these 2 lines are parallel. So this shape has got a single pair of parallel lines, and the quadrilateral with a single pair of parallel lines is a trapezium. Okay. B, write down the mathematical name of this 3D shape. You've got 2 choices here. You can either call it a circular prism, because it's got a uniform cross-section going all the way through, which is a circle. But a circular prism has got another more specific name, and that is a cylinder. Question 7, 42 pounds is shared equally between 3 friends. How much does each friend get? So if you're sharing, you're dividing, aren't you? So we're doing 42 divided by 3. That's the maths that we're doing. I'm going to do this by short division. So I'm going to have a little bus stop like this. I'm going to write the 3 at the front and the 42 under the bus shelter. 3's into 4 go once, remainder 1. 3's into 12 go 4 times, remainder nothing. We're all done. That's 14. So it's going to be 14 pounds. Question 8. Grace recorded the eye colour of each of the students in her class. The frequency table shows her results. So we've got eye colour and frequency as the headings on our 2 columns of our table. We've got blue, brown and green eyes, 10, 15 and 4 eyes. Grace then drew a bar chart below for this information. You can see the bar chart here. And the question is, write down one thing that is wrong with this bar chart. Okay, so what's wrong with it? So with these, I normally check the scale first, because that's nearly always the thing that's not right. But in this case, 0, 2, 4, 6, 8, 10, 12, 14, 16, that is fine. That's going up in even increments, starting at 0. So I'm going to give the scale in this direction a tick. In the other direction, I've got blue, brown and green. I've got equal spaces between my bars. So that's all good in that direction as well. So 2 ticks for the axes. The axes are labeled, so that's not the issue. So is it a problem with the actual data then? The bars are drawn properly. They're drawn with straight lines. They're shaded. They're spaced out. What about their heights? Let's have a quick check of the heights. So the first one should have been blue, which is a height of 10. Here's blue. Height is 10. That's no problem. Brown should be at a height of 15. Here's brown. Oh dear. There's the problem there, isn't it? So this bar here is the wrong height. Let's just double check green while I'm at it. Green should be 4. Here's 4. Here's green. Sorry, and that is at the height 4. So it's that brown bar height that is in error, isn't it? Okay. So what we're going to write down? We're going to write down write down one thing that is wrong with the bar chart. The bar representing brown eyes is the wrong height, and it is 16 instead of 15. Okay. Question 9. Danny buys 1 loaf of bread for £1.20, 1 bottle of milk for 70p, 2 packets of cheese for £2.30 each packet. Danny pays with a £10 note. He says, I should get £3.30 change. Is Danny correct? You must show how you get your answer. Okay, so what we're going to have to do is find out how much Danny should have paid. We're going to have to deduct that from 10 and see if it is actually £3.30 that he gets. That's my course of action. So let's go through and pull out the value. So we've got one lot of £1.20. So let's write that down. £1.20. I've got one lot of 70p. Now, don't forget that 70p is 0.70 pounds. And then I've got 2 packets of cheese at £2.30 each. So I could write that as 230, 230. I could just double it up now, can't I? I'm just going to double that up in my head. That's £4.60. So I'm going to add all those together. 0, 9, 9, 15. Carry 1, 1, 2, 6. So that's £6.50. I made that. Okay, so what is the change from £6.50? So if I've got £10 and I deduct £6.50, what do I get? 0 take away 5, can't do that, it's going to have to borrow 1 from there. So that becomes 10, but then I'm going to borrow 1, that becomes 9, that becomes 10. 10 take away 5 is 5, 9 take away 6 is 3. So that's £3.50. It's probably just as easy to add on to £6.50 and get up to 10 actually. So, but either way, you're going to get £3.50, which is not £3.30. So is he correct? No. Danny is wrong. He should have £3.50 in change. Silly Danny. Question 10. Rachel records the temperature in her garden at noon each day. On Monday, the temperature was 5 degrees Celsius. On Tuesday, the temperature was 10 degrees less than the temperature on Monday. And on Wednesday, the temperature was 3 degrees greater than the temperature on Tuesday. Find the difference between temperatures on Monday and the temperature on Wednesday. You must show all your work in. Okay. So we know the temperature on Monday, it was 5 degrees, and then we're going up and down the number line, aren't we? So I'm going to start off by drawing a number line. Let's go from, let's start at 0. Let's go up to 5 to start with. If I need to add more, I will. And let's go down to -5. So where am I starting? I'm going to start on Monday, and the temperature was 5 degrees Celsius. So let's mark that on the scale. So this is the temperature on Monday, isn't it? Okay. And then on Monday, so it was 5. So we've done that. And then on Tuesday, the temperature was 10 degrees less. So it's going down 10, isn't it? So let's bounce down the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to end up here, aren't we? Okay, so then on Tuesday, we're all the way down here now. So this is the temperature for Tuesday. Okay, then what? And then on Wednesday, the temperature was 3 degrees greater than the temperature on Tuesday. So now we're going up the number line, aren't we? Okay, so then from Tuesday, we're going up 3 jumps. So 1, 2, 3. We're going up to here. Okay, running out of colours. Let's go back to blue. So then that is the temperature then on Wednesday. Okay. So Wednesday is -2. Find the difference between the temperature on Monday and the temperature on Wednesday. So difference in mathematics means subtraction. So basically I need to subtract one from the other. So the temperature on Monday was 5 and the temperature on Tuesday was -2, and we need to subtract them from each other, and this was the difference then. Okay, so 5 subtract negative 2. Now 5 subtract negative 2, a minus, subtracting a negative is the same thing as adding a positive, isn't it? So that is 7. And you can also see it on the number line here. If you look at how far it is from here to here, it's 7 jumps. Okay, so answer is 7. Must show you all your work in. I think my number line is wonderful. I think that's good enough working for me. Let's move on. Question 11. The pictogram shows information about the number of video games sold in a shop on Monday, on Tuesday, and on Wednesday. Okay, and so we got a pictogram. We got some weird window-looking things inside, but luckily we got a key on the right-hand side that tells us how to read that. So this little window thing, which is made up of 4 little squares, represents 8 video games. Then presumably each one of the little squares inside the big window represents 2 video games, isn't it? Because it's a quarter of it. Okay, so if we look at Monday, then we've got 2 big windows. Each one is worth 8. 8 and 8 is worth 16. I don't know what I have to do yet. I'm just going to go through and count because we'll probably need to know. And then Tuesday, I've got 2 big windows. That's 8 and 8, 16 plus 3 parts out of the window. Each one of those is worth 2, isn't it? So that's going to be worth 6. So we've got 8 and 8, which is 16, plus 6, which is 22. And then on Wednesday, we've got a complete window, which is worth 8, plus 1 little pane there, which is worth 2, giving us a total of 10. Okay. So part A says, how many video games were sold on Monday? Okay, we've already answered that, haven't we? It's 16. 16. And part B says, more video games were sold on Tuesday than on Wednesday. How many more? Well, we're going to have to deduct one from the other to find out, aren't we? So then, how many more was it? It was going to be 22, which is the amount that they sold on Tuesday, minus 10, which is the amount they sold on Wednesday, giving you 12. So it was 12 more. They sold 12 more on Tuesday. On Thursday and Friday, a total of 32 video games were sold in the shop. A quarter of these 32 video games were sold in the shop on Thursday. Complete the pictogram for Thursday and Friday. Okay, so we need to know what a quarter of 32 was. So we know how many were sold on Thursday, and then we can work out how many were sold on Friday. So what is a quarter of 32? Well, finding a quarter of a number is the same thing as dividing it by 4, isn't it? So 4's into 32. There you go, 8 times. Okay, so I need to represent 8 video games on my Thursday pictogram day. Okay, so it's basically going to be 2 of those window things, isn't it? So I would do this with a ruler if I was in the exam, but I've got this silly computer thing here that the ruler is going to be a bit fiddly with. So I'm just going to kind of roughly draw them in today, but don't you do that. Do it nicely, please. And then, so then how many have we got for Friday then? So if I had 32 for the 2 days and I've used 8 for Thursday, then I'm left with 24 for Friday. So how many 8s in 24? That's 3, isn't it? So I'm going to need 3 of those window things to represent for Friday. So 1, 2, 3. Okay, so 8, 16, 24. Okay, we're done. Question 12. There are 2 drama groups in a school. In one group, there are 36 boys and 48 girls. In the other group, 3/7 of the students are boys and the rest of the students are girls. Anne says the ratio of the number of boys to the number of girls is the same for both groups. Is Anne correct? You must show how you get your answer. Okay, so let's have a look at group 1 first. So group 1 is this one here with 36 boys and 48 girls. So if I was to write that as a ratio then, so for group 1, the ratio of boys to girls then is 36 to 48, isn't it? Now I'm sure we can do better than that. I think we can cancel this down, can't we? Can you think of any common factors of 36 and 48? Both of those numbers are in the 6 times table anymore. Oh, they're in the 12 times table as well, aren't they? So I think 12 is a common factor of both those numbers. Can we go any higher? Nope, I think 12 is about the biggest. So ratios cancel down just the same way as fractions do. If you had 36 over 48 as a fraction, you could divide top and bottom by 12, couldn't you, to come up with a more simple fraction. We're going to do the same thing here with a ratio. We're going to divide both sides by 12, and we're going to simplify that ratio down. Okay, so 12s into 36 go 3 times, and 12s into 48 go 4 times. Okay, so that is a ratio of 3 to 4. Good stuff. Okay, let's move on to group 2. Group 2. Now we're told for group 2 that 3/7 of the students are boys and the rest are girls. Okay, so here we've got 3/7. When you've got a fraction like this, what you're doing with a fraction, you're comparing what you've got with everything, haven't you? Okay, so there are 3 boys out of every 7 students in this group. Okay, with ratio though, it's slightly different. You don't compare what you've got with everything. You compare what you've got with what you don't have. So if I've got 3 out of 7 which are boys, how many then are left over out of that 7? There are 4 left over. So if you've got 3 out of 7 boys, so you're going to have 4 out of 7 girls then, aren't you? The rest are going to be girls. So 3/7 are going to be boys, 4/7 are going to be girls. So then the ratio of boys to girls is going to be 3 to 4, isn't it? You've got 4 girls for every 3 boys. So the ratio of boys to girls is again 3 to 4. So is Anne correct? Yes, she is. Anne is correct. Both groups have a ratio of 3 to 4. Question 13. A sequence starts 1, 2, 4. Emma says that the next term is 7. Explain why Emma may be correct. Okay. Now with sequences, probably the best place to start usually is looking at the difference between the numbers and see what's going on there. So if you have you think about the differences here, the difference between 1 and 2 is 1, isn't it? So you add on 1 to 1 to get 2. And then if you have a look from 2 to 3, if you add on 2, you'll get from 2 to 4, won't you? Okay? So the first term to the second is add 1, and the second term to the third term is add 2. So you could see that Emma might be thinking that the third term might be add 3, which takes me to 7. Okay? So she could be right, couldn't she? So explain why Emma may be correct. I'm just going to say the difference could be increasing by 1 each time. Okay, I think that's clear enough because I've also demonstrated above on the diagram that it goes 1, 2, 4, 7. Okay. Now the reason why they've said may here is that, you know, with 3 terms you can't really nail a sequence down definitively. It could also be that it's going doubling each time. So double 1 is 2, double 2 is 4. That works, and then double 4 would be 8. So it doesn't necessarily have to be 7. With 3 terms there, it's really difficult to nail a sequence down definitively, but it could be that she's correct. So that's why it says explain why Emma may be correct. Okay, so then part B, here are the first 4 terms of the sequence of triangle numbers. Find the 8th term of this sequence. Triangle numbers are fun. This is the first. I like to draw them as triangles. So the first term 1 is 1 little dot like that. The second term is like that, isn't it? Got 3 dots which we can arrange like that. The third term looks like this, and then the fourth term, which you'll be familiar with if you play 10-pin bowling, looks like that. Okay, so 1, 3, 6, 10. So that's the first, second, third, and fourth term. Okay, first, second, third, fourth. Now note that these triangle numbers have the same number of dots at the bottom as the number you're in at the sequence. So I could, I could just sit here and draw out number 5 and 6 and 7 and then draw 8, but I know what the pattern looks like. So I'm just going to say for the 8th term, dot, 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 for the 8th term, I'm going to start with 1, 2, 3, 4, 5, 6, 7, 8 circles on the bottom. And then I'm going to have 7, 3, 4, 5, 6, 7. And then I'm going to have 6. And then I'm going to have 5. Then I'm going to have 4. Then I'm going to have 3. And then I'm going to have 2. And then I'm going to have 1 on the top. So that is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. How many is that then? So 8 plus 7 is 15, plus 6 is 21, plus 5 is 26, plus 4 is 30, plus 3 is 33, plus 2 is 35, plus 1, that is 36 altogether. So the 8th term of this sequence is 36. 36. Question 14. 3 kilograms of carrots cost £1.80. 2 kilograms of carrots and 5 kilograms of potatoes cost a total of £3.45. Work out the total cost of 4 kilograms of carrots and 2 kilograms of potatoes. You must show all your work in. Okay, so this has got the makings of a simultaneous equations question, isn't it? I'm going to say the cost of carrots I'm going to call C, and the cost of potatoes I'm going to call P, because I'm very imaginative. So then 3 kilos of carrots, 3C, is going to be equal to £1.80. I'm going to do it in just pence because I don't want to do with decimals. So 3C is 180. That's my my first equation. Now I've also got a second equation here. 2 kilograms of carrots and 5 kilograms of potatoes cost £3.45. So I'm going to write down 2C plus 5P equals 345. Okay, now we want to work out the cost of 4 kilograms of carrots and 2 kilograms of potatoes. So what is 4C plus 2P equal to? Okay, now in order to answer that question I need to know the cost of potatoes. I already know the cost of I know the cost of 3C, so surely from that I can work out the cost of 1C and then use that to work out the cost of my potatoes. So let's try and do that then. So let's take this first one then. 3C is 180. If I take that and I divide both sides by 3, I'm going to get C is equal to 60 then, isn't it? So if 3C equals 180 divided by 3, C equals 60. So then if I know that C is 60, I can substitute it into this second calculation. I know that 2 lots of 60 then plus my 5P must be equal to 345. Okay, what is 2 lots of 60? 2 lots of 60 is 120. So I've got 120 plus 5P is equal to 345. Now then subtracting 120 from both sides, they're going to cancel each other out, aren't they? So I'm going to be left with 5P on this side. 5P is going to be equal to 345 take away 120. That is 225 then, isn't it? So 5P is 225. So that must mean that P then is 225 divided by 5. 225 divided by 5. 5s into 2 don't go. 5s into 22 go 4 times. Remainder 2. 5s into 25 go 5 times. So that means P is 45. Okay. So now I know that C is 60 and I know that P is 45. I can now work out the cost of 4C plus 2P. 4C plus 2P then, that is going to be 4 lots of 60, because C is 60, plus 2 lots of 45, because P is 45. What's that then? 4 times 60, that is 240, plus 2 lots of 45, that's 90. Add them together, that is 330. Okay, so I worked that out in pence, if you remember. So what is the total cost of 4 kg of carrots and 2 kg of potatoes? So then the total cost, I'm just going to convert that into pounds and pence now. That's £3.30, isn't it? Okay. Question 15, time for a little bit of algebra. Got a few things to do here. Firstly, expand. We've got a single pair of brackets and some things inside the bracket, something outside. When you expand the brackets, you've got to remove them, and everything inside the bracket gets multiplied by the thing on the outside. So 2 times A is 2A, and 2 times D is 2D. So the answer is 2A plus 2D. Okay, factorize 6y squared minus 5y. This is pretty much the opposite process of what we've just been doing. We need to put the brackets back in, basically. So the way it works is you look for what is common to both terms. So what is in 6y squared and also in 5y? Well, the thing is that is in both of them is y, isn't it? So y is in 6y squared and y is in 5y. Now, y times what is 6y squared? Y times 6y is 6y squared. Y times what is 5y? Y times 5 is 5y. Okay? Now at this point, you might want to just then multiply it back out again. Just double check you got what you started from, but I'm pretty sure I've got it right. And then finally, C, solve 4x minus 7 equals 37. So I've got a linear equation here. 4x minus 7 is equal to 37. So when we're trying to solve an equation, we're trying to get x on its own. Normally when we do maths, we follow BIDMAS, don't we? Brackets, indices, division, multiplication, addition, subtraction. So we normally go through BIDMAS in this direction, from brackets to subtraction. When we're unwinding or solving equations, we kind of have to approach the operations backwards. So we're going to work our way backwards through this list. So here, if you think about it, I've got 4 times x, which is a multiplication, and I've got a subtract 7, which is a subtraction. So normally I would do the multiplying first and then the subtraction, but when I'm kind of unwinding this equation to solve it, I go through backwards. So I'm going to deal with the subtraction first. Now the opposite of subtract 7 is add 7. So if I add 7 to both sides, on the left hand side, they're going to cancel. It's going to leave me with 4x on the left, and on the right, 37 plus 7, well, that's 44. Okay, so I've dealt with the subtraction. Next thing up is to deal with the multiplication. The opposite of multiplying by 4 is dividing by 4, so divide both sides by 4. 4x divided by 4, they're going to cancel. It's going to leave me with x, and then 44 divided by 4, well, that is 11. So the answer is x is equal to 11. Question 16. ABCD is a kite. And we got the picture of the kite here, and we've been given one of the sides of the kite, haven't we? And it says AB equals 4x minus 2. Well, that's the same thing, isn't it? AB is this side here, is equal to 4x minus 2. Jasper says that x could be 0.5. Explain why Jasper cannot be correct. Well, that's interesting. Why can't he be correct? ABCD is a kite. AB equals 4x minus 2 centimeters. Why can't x be a half? Well, I'll tell you why it can't be a half. Because if x is a half, if x is 0.5, then AB would be 4 lots of 0.5 take away 2, wouldn't it? Okay, and 4 lots of 0.5, or 4 lots of a half is 2, and 2 take away 0, 2 is 0. Okay, so that means that this kite would have the length AB is equal to 0, so that side would disappear, and also this one would as well, because they're the same size, aren't they? So those two sides would disappear, and so you'd be left with a straight line and not a kite. Okay, so that's the reason why it can't be 0.5, because AB would disappear. So AB would disappear. Okay, and then onto part B, AD equals 3 lots of AB. The kite has perimeter of 64. Write down the value of x. So we're told that AD, that's this side here, is going to be 3 lots of AB. AB is 4x minus 2. So 3 lots of that would be 3 lots of 4x minus 2. Okay? Now, kites have 2 pairs of equal lengths, don't they? So that one is the same as AB, and that one is the same as AD. Okay? So this one is also 4x minus 2, and this one then would also be 3 lots of 4x minus 2. Okay? So then if I was going to work out the perimeter of this shape, I'd need to add all of those sides together. Okay, so starting at the top of my shape and kind of going round, I'm going to get 4x minus 2 for AB. BC is going to be 4x minus 2 as well. And then I'm going to get CD, which is 3 lots of 4x minus 2. And then I'm going to get AD, which is also 3 lots of 4x minus 2. Okay? So what's that then? That's quite a lot, isn't it? That's a lot of 4x minus 2s. So if you think about it, I've got 3 lots of 4x minus 2, another 3 lots of 4x minus 2, and 1 lot of 4x minus 2, and 1 lot of 4x minus 2. How many 4x minus 2s is that? So there's 3, 6, 7, 8 of them. So I could just summarize that and say, well, that's 8 lots of 4x minus 2, and then multiplying 8 times 4, 8, 16, 24, 32. That's 32x minus 16, I make that. All right, and so then I know that the perimeter, though, it's been given in the question, the perimeter was given as 64 centimeters. So I can equate this with 64. Okay, so then it's just a matter of solving this linear equation then. Add in 16 to both sides. They're going to cancel, and that's going to leave me with 32x is equal to 64 plus 16, 74, 80. Okay, and then x then is going to be, if I divide both sides by 32, they're going to cancel, leaving me with x. X is going to be 80 over 32. Bit of a weird fraction. Can I cancel that down? Well, they're both even, so I could halve them. So that'd be 40 over 16, which I could halve again, which would be 20 over 8. Which I could halve again, which would be 10 over 4. 10 over 4, which I could halve again, which would be 5 over 2. See, that'd be easy, wouldn't it? 5 over 2. So 2's into 5 go twice, remainder 1. So that is the same thing as x being 2.5 then, isn't it? Or 2.5. Okay? X is 2.5. Question 17. Heidi wants to make some biscuits using this recipe. And the recipe makes 12 biscuits and requires 125 grams of butter, 200 grams of flour, and 50 grams of sugar. Heidi thinks that she has 500 grams of butter, 700 grams of flour, and 250 grams of sugar. Assuming that these weights are correct, work out the greatest number of biscuits Heidi can make. You must show all your work in. Okay? Well, if I take what she's got and divide it by what she needs, that will tell me how many versions of the recipe she can make with that ingredient. So let's start with the butter. She's got 500 grams. She requires 125 grams for 12 biscuits. So how many times does 125 go into 500? So 500 divided by 125, well, 125 doubled is 250, doubled again is 500, so it goes in 4 times. Okay, so she can make 4 lots of the recipe with the amount of butter that she has. Okay, for the flour, she's got 700 grams and she requires 200 grams. Okay, so how many times or how many lots of that recipe can she make with 700 grams? 700 divided by 200, so just cancel all those zeros off. 2's into 7, go 3 times remainder 1, so it's actually 3.5, isn't it? So that's 3.5. So it goes in 3.5 times. And then sugar is going to be 250 grams divided by, here's 250 grams and 50 grams, isn't it? So that's 250 divided by 50, which goes in 5 times. So she could make the recipe 5 times over with the amount of sugar that she's got. So the limiting factor is going to be this one then, isn't it? Okay, so she's going to run out of flour before she gets around to making all those biscuits that she could make with the butter and the sugar, because the flour is the smallest amount. So she can make 3.5 times her the recipe with the amount of flour that she's got, and then she's got enough butter and sugar to make the rest of the biscuit recipe. Okay, because she's got plenty of those. So what is 3.5 lots of 12? So she can make 12 biscuits per kind of go around that recipe, and we've worked out she can go around that recipe 3.5 times. So the number of biscuits she can make then is going to be 3.5 lots of 12, isn't it? So 3.5 lots of 12. So 3 lots of 12 would be 36, and half a lot of 12 would be 6. So adding that together, that's going to be 42. So she can make 42 biscuits maximum. Okay. And then she's going to be out of flour. She'd still have a little bit of butter and sugar left over, but you know, can't make a biscuit out of just butter and sugar. Hold your horses. I thought we were done, but no, Heidi is wrong. She has more than 250 grams of sugar. Does this affect the greatest number of biscuits Heidi can make? No, it's not going to have make any difference at all, is it? The limiting factor was flour, not sugar. So even if she's got like a bazillion grams of sugar, she's not going to be able to make any more biscuits, is she? So does it affect the number of biscuits that Heidi can make? No. The limiting factor was the amount of flour. So with more sugar, she still cannot make any more biscuits. Boo-hoo. Okay, yeah, so she's stuck. She can't make any more because it's the amount of flour that's holding her back. Question 18. On the grid below, draw the graph of y equals 2x minus 2 for the values of x from minus 2 to 3. Okay, so we're going to have to draw this graph here. Now, what sort of graph is this? Do you know? Y equals 2x minus 2. Now, this is of the form y equals mx plus c, isn't it? It's the equation of a straight line where the gradient is 2 and the intercept is minus 2. So we know it's going to be a straight line. Okay. Now, you can actually draw a graph from its gradient and intercept if you want to, but probably it's easier to do it from a table of values. Okay. Now, we want to draw the graph from minus 2 to 2, which is, look, minus 2 to 3, which is from here to here, isn't it? So what I'm going to do is I'm just going to pull out all those values. Minus 2, minus 1, 0, 1, 2, 3. You can draw a line with 3 points, but if you've got a few more, you can use them as a check, okay, that you haven't made a mistake. Okay, all your points should lie in a straight line because it's a straight line graph. So the more points you get, the more confident you can be that you've got all your points correct and it's all plotted nicely. Okay, so I'm going to take each one of those values and sub it into the equation and find the corresponding value of y. So I know that y equals 2x minus 2. So if x is 3, what does that make y? Y then would be 2 lots of 3 minus 2, which is 2 lots of 3 is 6. Take away 2, that's 4. So when x is 3, y is 4. I'm starting at the positive end because that tends to be a little bit easier. And by the time it gets harder down to the negative ones, you can normally see the pattern to help you. So when x is 2, y is going to be 2 lots of 2 minus 2. 2 lots of 2 is 4. Take away 2 is 2. So 2 goes with 2. When x is 1, y is going to be 2 lots of 1 minus 2. 2 lots of 1 is 2. Take away 2 is 0. Okay. When x is 0, then y is going to be 2 lots of 0 take away 2. 0 take away 2 is minus 2. Minus 2. Can you see the pattern is going down in 2's, isn't it? So I can probably already work out that's minus 4 and minus 6. But let's just double check. X is minus 1. Y is going to be 2 lots of minus 1. Minus 2. 2 lots of minus 1 is minus 2. Take away 2 is minus 4, which is what we suspected. And then finally, x is minus 2 gives us y is equal to 2 lots of minus 2 minus 2. 2 lots of minus 2 is minus 4. Take away 2 is minus 6. Okay, it's minus 6. Like I say, after you've done a few of these, because you know it's a linear equation, it's going down in equal jumps, they should go down in equal jumps as well. So you can probably work them out without bothering to do all the table down there. Anyway, I've got them all. Let's start plotting the points. So each one of these on here, you can plot as a separate point on your graph. So the first one up I've got is minus 2, 6. So negative 2 across, and the negative 6 is down. So my point is here. Next one, minus 1, minus 4. Minus 1, minus 4 is here. Then I've got 0, minus 2. That's there. Then I've got 1, 0, which is there. And then I've got 2, 2, which is there. And then I've got 3, 4, which is up there. Okay, so hopefully you can see that all my points are lying in a straight line, as I thought they would. So just to finish it off, I'm just going to join them up with a straight line. Don't start and end with your first and last point. You should kind of extend the full length of the graph, really. Okay, and there's my graph. Let's move on. Question 19. Robin buys a watch for £80. He sells the watch for £56. Work out his percentage lost. Okay, well, how much has he lost? We can work that out by subtracting one from the other, can't we? What is 80 take away 56? 80 take away 50 is 30. Take away another 6 is 24. So he's lost £24 in the time that he had it. Okay, and what is that as a percentage of the total that he had? Okay, so it was 24 and it was out of 80. Now, if I want to take this and turn it as a percentage, I need to get this as a fraction over 100. Okay, now I don't know what 80 times what I'm going to get to turn it into 100, but sometimes it's easy to go via a stepping stone along the way. Okay, I could write 10 there, and then I could go from here to here by dividing by 8, and then I can go from here to here by timesing by 10. So I'm going to do the same thing with the number on the top. So I'm going to take 24 and I'm going to divide it by 8. So 24 over 80 is the same thing as 24 divided by 8. 8 into 24 goes 3 times. So 24 over 80 is the same thing as 3/10. Then times in top and bottom by 10. We're going to get 30 over 100, which as a percentage is 30%, isn't it? So that is his percentage loss. So his percentage loss is 30%. Okay, it's lost 30% of the value of the original value of the watch. Work out 3.67 times 4.2. Presumably you know how to do column multiplication. This is the non-calculated paper, so you need to have a decent way of multiplying, don't you? Okay, so 7 2s are 14, carry 1. 6 2s are 12, plus 1 is 13, carry 1. 3 2s are 6, plus 1 is 7. And then next row, 4 7s are 28, so 8 carry 2. 6 4s are 24, plus 2 is 26, so 6 carry 2. 3 4s are 12, plus 2 is 14, so 14. There we go. And then adding it up, 4 and 0 make 4, 3 and 8 make 11, so that's 1 carry 1. 6 and 7 make 13, plus 1 is 14, that's going to be 5. And there we go, 15414. Okay, but remember we've got how many decimal points in the question? We've got 1, 2, 3 appearing there after the decimal point in the question. So we're going to have 1, 2, 3 appearing after the decimal point in the answer. So it's going to be 15.414. If you're not sure you got the decimal point in the right place, just round the numbers off and multiply them and get a feel for the size of the number. So like rounding those off, it's 4 times 4 is 16, isn't it? So it's of the right sort of magnitude. So part B, we've got 59.84 divided by 1.6. So we're going to be dividing by a decimal. I don't really like that, really, to be honest. I'm going to just times top and bottom by 10, I think, to get rid of that that decimal there for the divisor. So if I multiply both parts by 10, we're going to be dividing one by the other anyway. So if I scale up the top and the bottom by a factor of 10, it's a bit like writing an equivalent fraction down, isn't it? It doesn't change the value. So that would be 598.4 divided by 16. So 16 is my divisor into 598.4. So 16s into 5 don't go. 16s into 59. So what's that? That's 16, 32, 48 and over, is it? 48, 58, 60. Next one would be 64, which is too much. So it goes in 3 times. So 3 16s are 48. That's the remainder of 11, isn't it? So I'm going to squeeze in 11 there. So then 16s into 118. I'm going to have a few more on my list, aren't I? So 64 is 80 next, then 96, 100 and what's that? 112. One more? No, one more would go over, wouldn't it? So the next one would be 128, which would be one too many. So what's that? 1, 2, 3, 4, 5, 6, 7 times. So that goes in 7 times. So 16 times 7 is 112. So that gives me a remainder of 6 this time, doesn't it? So the 6 goes there. And then 16 into 64 we can see is there. It's 4 times, isn't it? Okay, decimal point is here. It's going to be here in the same point in my answer. It's going to be 37.4. We've got a Venn diagram here, and we're asked to complete the Venn diagram for this information. The information is up here. I've got E, the universal set. That's equal to even numbers less than 19. I'm just gonna list those out quickly. It won't take me very long. Even numbers less than 19. So that's 2, 4, 6, 8, 10, 12, 14, 16, and 18, isn't it? So that's that set there. They're the values that they're all the values that are going to be on this diagram. Now, some of them are going to be inside these circles. Okay, taking a look at sets A and B, you can see that they've got 2 elements in common, haven't they? I've got a 6 that's in both and an 18 that's in both. Okay, so those 2 elements belong in the center, in the intersection of these 2 sets. So the 6 belongs here, and the 18 belongs in the middle as well. Okay, now I've got one number left over in the set A. Okay, so that's going to have to go here. Look, so inside set A, but outside the intersection. And then with B, I've got 2 and 14, so they belong inside set B, but not in the intersection. So 2 and 14 belong here. Okay. Now, I haven't quite finished yet because my universal set has got all those numbers here, and I've only got a few of them down. So let's just go through and tick off the ones we already had. So we had 6 and 18 in the middle, didn't we? And then we had 12 in the left-hand set, and then we had 2 and 14 in the right-hand set. So then these ones that are left over then need to go outside those 2 sets. So 4, 8, 10 we haven't had yet, and 16. So they belong inside the universal set, but outside set A and B. Okay, just gonna double check I've got the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it all matches up. Good. Let's move on. Work out 4 1/5 minus 2 2/3. Give your answer as a mixed number. Okay. Well, they're already mixed numbers, aren't they? But they're not super easy to add up when they're mixed numbers like that. So probably the easiest thing is to convert them both into top-heavy fractions, then find a common denominator, then do the subtraction, and then convert them all back again. Okay. So let's take the first one, 4 and 1/5. Now to convert it into an improper fraction, what we do is we multiply those two together, the whole number with the denominator, and then we add on the numerator, don't we? So 4 times 5 is 20 plus 1 is 21. So 4 and 1/5 is the same thing as 21 over 5. Okay, let's do the same thing with the other one. So we've got 2 and 3 there. So 2 times 3 is 6. And then add on that one there, it gives me 8. So that makes 2 and 2/3 the same thing as 8/3. So minus 8/3. Okay, we're making progress. Okay, next step is to find a common denominator, isn't it? Now the lowest common multiple of 5 and 3 is going to be 15. So I'm going to make these as fractions over 15. How many times does 5 go into 15? It goes in 3 times. So multiply top and bottom by 3. That's going to make 63 out of 15 or over 15. So 63/15. How many times does 3 go into 15? It goes in 5 times. So multiplying top and bottom by 5. 8 times 5 is 40. So that's the same thing as 40/15. Okay. Right, now we're cooking on gas. Right, so what's going on here now? I've got two numbers with the same denominator, so if I want to subtract them, then I just subtract the numerators then, don't I? So 63 minus 40, that is 23. So 23/15. Are we done? Not quite, because the answer says, well, the question says, can you give it to me as a mixed number? This is not a mixed number. This is still a top-heavy fraction. So how many times does 15 go into 23? 15 goes into 23 once. Remainder 8. So that's 1 and 8/15 as a as a mixed number then, isn't it? So 1 and 8/15. Final answer. At the end of 2017, the value of Tamara's house was £220,000, and the value of Rahim's house was £160,000. At the end of 2019, the value of Tamara's house has decreased by 20%, and the value of Rahim's house has increased by 30%. At the end of 2019, whose house had the greater value? You must show how you got your answers. Okay. Now this is the non-calculated paper, so I'm going to use a non-calculator approach. I'm going to start off with Tamara's house. Let's start with Tamara. So Tamara. Now 100% of the value of her house was 220,000 then, wasn't it? Now I want to work out what I want to do a 20% decrease. In other words, I need to find out what 20% is and then take it away, don't I? So what's 10%? 10% is going to be that amount divided by 10. So, or kind of scratching a 0 off the end. That's going to be £22,000 then, isn't it? So then 20% is going to be twice that. That's going to be £40,000. Okay, £44,000, sorry. So then if I want to find 80%, I want to then take my 100% and I want to minus that there then, don't I? I want to take that away. Okay, so what is, so 100% take away 20% is 80%, and 220,000 minus 44,000, so 220 take away 44, and we'll take away 40 would take me down to 180, take away another 4 is 176, isn't it? So that's £176,000. Okay, so that's Tamara's. Let's have a look at Rahim's situation. He's doing rather well. His is going up, isn't it? So his started out at £160,000. Okay, so then we're going to do a similar approach. Let's find 10% first. 10% is going to be £16,000 then. So then 30% is going to be 3 lots of 16,000. 16, 32, 48,000, isn't it? Okay, his house has gone up a lot. So then 100% plus 30%, what's that then? That's going to give me 130% here, and 160,000 plus 48,000. 160 plus 40 is 2,000. Is 200. Sorry, plus another 8 is 208. 208,000. Okay. So let's answer the question, whose house had the greater value? Rahim's house greater. And then we're just going to say that 208,000 is bigger than 176,000. Okay. Rosie, Matilda and Ibrahim collect stickers. And I've got a ratio here. It says the number of stickers Rosie has to the number of stickers Matilda has to the number of stickers Ibrahim has are in the ratio of 4 to 7 to 15. Now, Ibrahim has 24 more stickers than Matilda. Ibrahim has more stickers than Rosie. How many more? So let's have a look at these ratios. We've got Rosie to Matilda to Ibrahim, and they are in the ratio of 4 to 7 to 15. Now, I don't know how many stickers Matilda had, but I do know that Ibrahim had 24 more. Okay, so I'm just going to draw a quick bar model to think about this. Okay, so I'm just going to draw a quick bar model. So let's divide it up. So remember, Rosie has 4, Matilda has 7, and Ibrahim has 14. That's the kind of ratio. It doesn't mean that's how many stickers they've got. That's the ratio that their stickers are in. Okay, what I'm going to do is I want to just compare Matilda's and Ibrahim's bar. Okay, so this bar here is worth 7, wasn't it? Okay, now if I pick that up and move it over here next to Ibrahim's, so we can see that if Matilda has 7 stickers for every 15 stickers Ibrahim has, then that kind of means that Ibrahim has an extra 8 stickers for every an extra 8 stickers compared to every 7 that Matilda has, doesn't he? So that's going to be 8 in there. But we're told that actually Ibrahim has 24 more stickers. So those 8 shares there are actually worth 24 stickers. Okay, so those 8 shares are worth 24 stickers. So then what is each share worth then? Then each share then is going to be worth 3 stickers. So 1 share equals 3 stickers then. Does that make sense? So then if 1 share is 3 stickers, then this one here is going to be worth 21 stickers, or 21 here. Ibrahim's going to have 15 lots of 3. He's going to have 45 stickers altogether. And Rosie's going to have 4 times 3. She's going to have 12 stickers to start with. Okay, so if Ibrahim has got 45 stickers and Rosie has 12 stickers, how many more does Ibrahim have? Then Ibrahim has 45 stickers minus 12 stickers. He's going to have 33 more stickers compared to Rosie then, isn't he? So Ibrahim has 33 more stickers than Rosie. The diagram shows a prism. The cross section of the prism is a right angled triangle. The base of the triangle has a length of 5 centimeters. The prism has a length of 25 centimeters. The prism has a volume of 750 centimeters cubed. Work out the height of the prism. Okay. So let's just go through and make sure all that information is actually on the diagram. The cross section of the prism is a right angled triangle. So the cross section is the kind of uniform face running all the way through the prism. It's that face there, isn't it? It kind of matches up with the one on the other side. And yeah, the right angle has been marked. Okay, so that's on there. The prism has a length of 25 centimeters. That's been marked there. And it has a base of the triangle is 5. That's on there. The volume of the volume of the prism is 750 cubic centimeters. That's not marked on there. Let's just kind of add it to our diagram. So this has got 750 cubic centimeters. I like to have everything there on the diagram so I can see it all together. Work out the height of the prism. Okay, so what we're going to have to do is we're going to have to use the volume of a prism formula because we've got most of the information here, and kind of work backwards to get the height. Okay, now the volume of any prism is cross-sectional area times its length. Okay, so the cross-section of this shape is a triangle, isn't it? And the triangle formula is half base height for area, isn't it? So area is half base times height. So you can use half base times height to find the area of that cross section, and then what you do is you take the area of the cross section and you multiply it by the distance between the front and the back face, which is 25 in this case, and that will give you the volume. Okay, so the volume of a cuboid is cross sectional area multiplied by length. Okay, and as I said, in this case the cross-sectional area is a triangle, so it's going to be half base height, and I'm going to multiply that by the length. Okay, so subbing in what I know, I actually know the volume. The volume is 750 centimeters cubed, so I'm going to write 750 at the front here. Okay, I know half, it's half. Now I know the base. The base is this line here, it's 5, so let's sub that into 5. Height, I don't know. Height is the one I'm trying to find. I'm just going to leave in h for now. And L I do know. L is the length, isn't it? So the length is 25. Okay, so now I want to try and make h the subject. I want to get h, don't I? I want to solve for h. So I want to get h by itself. Now I've got that pesky half in there. I'm just going to get rid of that by multiplying both sides by 2 to start with. I normally see if I can cancel it in one of the other numbers, but they're all odd, so that isn't going to work. So I'm just going to get rid of it by multiplying both sides by 2. So 2 lots of 750, that is 1,500. The half and the 2 will cancel on the other side, leaving me with 5 times h times 25. Now, 5 times 25 is 125, isn't it? So I'm just going to simplify that at the same time to 125h. Okay? So then to get h, I'm going to have to divide both sides by 125 then, aren't I? Okay? That will cancel with that there, leaving me with just h on the right. And then all I really need to know now is how many times 125 goes into 1,500. I can do that by counting up. 125, double it is 250, and then 250 doubled again would be 500, and 500 fits in 3 times. So I make that 12 times then, isn't it? Okay, so that makes the height equal to 12. 12 what? 12 centimeters, isn't it? So h equals 12 centimeters is my final answer. The diagram shows a cube with edges of length x centimeters and a sphere of radius 3 centimeters. The surface area of the cube is equal to the surface area of the sphere. Show that x equals the root of k times pi, where k is an integer. Oh, what fun. Now this is a very interesting question, isn't it? Okay. Right, so we've been given the surface area of a sphere formula over here. Look, that's going to be very useful. The surface area of a sphere is 4 pi r squared. So I guess that's where we need to start, isn't it? Because we actually know the radius of the sphere we've been given, and that's the only thing I need to know in this formula to find the surface area. Okay, so let's start with the surface area. So surface area of sphere. Surface area is equal to 4 pi r squared, which is equal to 4 times pi times 3 squared. Well, 3 squared is 9, and 9 times 4 is 36. So that means that the surface area of this sphere is going to be 36 lots of pi. Okay, so that wasn't actually that hard. Okay, now over to the cube. It's a cube, isn't it? Yeah, it's a cube. That means all the sides are the same length, isn't it? So we've got x, x, and x. So what is the surface area of a cube? Surface area of a cube. Well, with a cube you've got 6 faces, haven't you? I've got 6 faces, and each face has an area of its length times its length, which in this case is x times x. So each face has an area of x squared, and there are 6 of them, so that gives me a total of 6x squared. Okay, so I've got my surface area of my cube, which is 6x squared, and I've got my surface area of the sphere, which is 36 pi. Now we're told that these two things are equal to each other. Okay, so I can now equate those. So I can write underneath that 6x squared equals 36 pi. Okay, so I'm guessing then I want to try and get x by itself. Let's try dividing both sides by 6. That's going to leave me with x squared on the left, and 6 goes into 36 6 times, so that's going to leave me with 6 pi. Okay, oh, that's a lot easier than I thought. Then I'm just going to have to square root both sides then, aren't I? Square root both sides. Square root is the opposite of squaring, so if I square root x squared, I'm going to get x, and if I square root 6x, I'm going to get root 6 pi. Sorry, if I square root 6 pi. And that's it, look, so it's in the right form. X equals the square root of some constant times pi. So my constant is 6, isn't it? So k is 6. Okay, all good. Not so hard. It looked horrible to start with, but actually it wasn't too bad. Question 27. Freddie measured the length of a pencil as 7.2 centimeters, correct to 1 decimal place. Complete the error interval for the length p centimeters of the pencil. Okay, so when I've got one of these error interval questions, I like to take the value that they give me, that it's been rounded to, and draw that on a number line. Okay, so that is going to be at 7.2. Okay, next what I do is I take the number of decimal places, or the degree of accuracy it's been rounded off to, and I go that amount up and down from my given number. So I'm going to go 1 decimal place, or a tenth, up from 7.2. So a tenth up from 7.2 is 7.3, and a tenth down from 7.2 is 7.1. So 7.1 and 7.3 would be the numbers it rounded to if it was a little bit bigger or a little bit smaller than what it currently is. Okay, so it's going to round to 7.2 then if it is closer to 7.2 than it is from 7.1 or 7.3 then, isn't it? So the points that lie equally distant from the two are the halfway marks. So if I put a line at halfway between those, then all the points that are halfway between those numbers or nearer, they are the ones that round off to 7.2, aren't they, if you're going to round it to 1 decimal place. But what is that number there, which is halfway between 7.1 and 7.2? That is going to be 7.15, isn't it? And then halfway between 7.2 and 7.3 is 7.25. Okay. Now, so that one on the left, the smaller one, and that's what we call the lower bound, and the lower bound goes here. Okay, so my lower bound is this one here, so that's going to go on the left hand here, 7.15. And then the other number on the other side is what we call the upper bound, isn't it? The upper bound, which is this one up here, 7.25, and that's what goes on the other side. So 7.25, and that's it. That's my error interval. P must lie between 7.15 and 7.25. Now you might be thinking, well, 7.25 rounds up to 7.3, so why is it part of the boundary of my answer? Well, if you have a look at the symbols here, it says P is greater than or equal to 7.15, so it can actually be equal to 7.15, but it's strictly less than that right hand limit. So it could be 7.2499999, really close to 7.25. And whilst 7.25 strictly rounds up, we still use it as the upper bound because it's the point where we switch from rounding down to rounding up. Okay. Hope that makes sense. Anyway, it's 7.15 and 7.25. Question 28. The equation of a straight line L is y equals 3 minus 4x. Write down the gradient of L. Now we mentioned earlier that the equation of a straight line has the form y equals mx plus c. So we can compare this general form with what we've been given, and we should be able to read out the gradient and the intercept straight from the question. Now just take care, because they've written these things the other way around, haven't we? So like the gradient m is the coefficient of x, the number in front of x, and actually they've written that as the second term here because it's negative. So the gradient there is minus 4, and the y-intercept is the bit at the front here. That's the c value there. Okay, so they've written it the other way around because the m value is negative. Okay, so what is the gradient then? The gradient then is going to be negative 4. Okay, negative 4. Write down the coordinates of the point where L crosses the y-axis. Now, where this line crosses the y-axis is going to be the y-intercept, isn't it? That is what the y-intercept is. The y-intercept is where it crosses the y-axis. So we already found above that c must be equal to 3. So that value there is 3. But it doesn't ask what value of y it crosses the y-axis for. It actually asks for the coordinates. So what coordinates has that got then? The x-coordinate is going to be 0. And the y-coordinate is going to be 3. So the coordinates of the point where L crosses the y-axis is 0, 3. All done? You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.